we're going to look at something called a definite integral. And if you look at the definition of a definite integral, which I have right here, you will see that this is the integral symbol right here. That's that funky little symbol like that. And we call that an integral from a to b of f of x dx. And basically what this means is the area under the curve of the function f of x from point A to point B, where a is less than b. All right, so what we're going to do is we are going to look at an example. So look at the example that we have below. So I have a function, and it kind of looks a lot like a trapezoid, doesn't it? So what I'm going to ask you to find is the integral from -2 to 4 of f of x dx. Now remember what that means. It's basically asking the area under the curve from -2. And if we look right here, we can see that -2 is right here and 4 is right here. So basically what we're doing is we are looking for the area under the curve, which is this space right in here, which is a trapezoid. So simply all you're going to do is 1/2 the height, base 1 plus base 2, oops, and that will give us the area under the curve. So we have a height of 2. The bottom base is, let's see, 1, 2, 3, 4, 5, 6, and the top base is 2. And then you just compute that, and you will end up with 8. So the integral of this function from -2 to 4 is 8. Let's look at another example. Now this one's a little bit more complicated. So again, we've got a picture, and this time we're going to be integrating from 0 to 5. Now my graph doesn't quite go out that far, but we're going to put 5 right there. Okay, so now in this case what you're doing is you're looking for the area under the curve. Now we have to kind of split this up a little bit. So we're going to look at this space in here, then we're going to look at this space in here, and then we are going to look at this space right there. So if you look at that, we can actually split this integral up into 3 parts. We can look at the integral from 0 to 2. Then we can look at the integral from 2 to about, let's see, what do we think that is? Well, this is 2, 3.5 is what I would say. So 3.5. And then we're going to look at the integral from 3.5 to 5. So essentially what we're going to do is find the area under the curve at 3 separate spots, because they're 3 separate triangles. So since we're going to do the triangle formula, we do 1/2 base times height. And let's look at the first one. From 0 to 2, the base is 2, and the height is 2. So the area for that section is 2. Then we look at that tiny little triangle there. Now notice though, we have to be very careful because that triangle is underneath the x-axis. So there's going to be a slight change there, and I'll talk about that in a minute. So with that one, the area will be 1/2. Now the base of that one is 1.5, so I'm going to write that as a fraction, so 3/2, and the height of that triangle is 1. So we end up with an area of 3/4. Now, because that area is below the x-axis, we are going to actually end up taking this number and we're going to subtract it. We consider that area to be negative because it's underneath the x-axis. All right, so let's keep going. So if we go from 3.5 to 5, we're going to have 1/2, and again, the area, the base would be 1.5 or 3/2 times the height, which would be 3. And when we work that all out, that's 9/4. Okay? Now, both the integral from 0 to 2 and the integral from 3.5 to 5 are positive. So what we can do then is we can do, I'm going to change 2 to 8/4 if that works for you guys. So I'm going to do 8/4. I'm going to subtract 3/4, again because that area is below the x-axis. and then I'm going to add 9/4, and that will give me the total integral from 0 to 5. So 8/4 minus 3/4 would be 5/4, and then 5/4 plus 9/4 would be, and I'm going to throw that up here, 14/4. Now, if you want, you can reduce that, and that would be 7/2. So that would be the area under the curve from 0 to 5. And again, let's take into account that this area right here is special because it's below the x-axis. So that area is going to need to get subtracted. The last one we're going to look at is actually where we do not have a picture, but we actually have an equation. Now, we have talked about vertical shifts and horizontal shifts, so hopefully you realize that this is an absolute value equation. Remember, that's a V with the minimum pointing at 0, 0, or on 0, 0, I should say. But we have a shift here, and we have a shift to the right 2 units. Now, FYI, if you do forget that, what you can do is just take whatever's in the absolute value, and if you set that equal to 0 and solve, that will tell you where your 0 is for this particular graph. Okay, so that will always work as well. Now, as far as that, we should know that an absolute value will have a slope of 1 if we're to the right of this point that's at 2, 0, or a slope of -1 if we're to the left of that point 2, 0. Now, if you forget that though, what you can do is you can look at your bounds that they give you right here, and we see that we have a bound of -1 and we have a bound of 3. And what that will tell you is to plug in all the numbers from -1 to 3, the whole number x values, into your absolute value equation right here. Okay, so in other words, if I put in -1 into x minus 2, I'll get -3. So then I know that this point at -1 would go 1, 2, 3, and I can put a dot right there. Okay, if I plug in 0 into the absolute value of x minus 2, I would get I would get +2. What am I saying? Silly me, because it's absolute value. Okay, and if I plug in 1, 1 minus 2 is -1. Again, absolute value, though, would give me +1. And then I can do the same thing for 3. 3 minus 2 is 1. Take the absolute value of that, and that would be 1. Okay, so if you end up with an equation and you're not sure of what it looks like, take your bounds, in this case the -1 all the way up to 3, and plug those bounds into the equation, and that should give you an idea of what your picture looks like. All right, so what we do have here is we have an absolute value, and it's got a slight shift. Okay, so we're going to be looking at this space right in here, and then we're going to be looking at this space right in here. So we can see, once again, like the last example, that we have 2 triangles. So I'm going to first start by integrating from -1 to 2. Okay, that's the triangle here on the left. And then I'm going to integrate from 2 to 3, which is this tiny little triangle there on the right. Now notice that both of these triangles are above the x-axis, so we don't need to do any subtracting. We just need to add the areas. All right, so let's look at -1 to 2. So we're going to do 1/2, and we're going to count the base, 1, 2, 3, and we're going to count the height, and that's also 3. So the area from -1 to 2 would be 9/2. And do the same thing from 2 to 3, so we have 1/2. The base is 1, and so is the height. So the area from 2 to 3 would be 1/2. Again, both these triangles are above the x-axis, so all we need to do is add. So that would give us 10/2, which would give us 5. Okay, so basically that is how we deal with definite integrals. When you do have a picture and you're able to take the area under the curve, because the area is something that we're familiar with, whether it be a triangle, a trapezoid, it could be rectangle, it could be circles. Now what I'd like you to do is take the worksheet that I gave you and work on that, and we will go over that tomorrow.